Hi, my name is Damla Welti, and I'm excited to present our research titled Spatial Perspective Taking in Interior Design, a comparison of world in miniature and cross-reality. Understanding spatial relationships is fundamental but challenging. One key skill is spatial perspective taking, or SPT. SPT is the ability to mentally shift one's viewpoint and imagine a space from another position without actually moving. This skill is essential in everyday life. For example, when choosing a good theater seat or driving a car. It's even more important in professional fields like urban planning, architecture, and interior design. In these fields, professionals must evaluate sightlines, visibility, and how a space feels, often before anything is built. That makes strong SPT skills crucial. Virtual environments can help with these demands. Mixed reality, or MR, blends the real world with virtual content and allows to overlay digital models at accurate scale and depth. However, MR has a limitation. Navigation relies on physical walking. This makes it difficult or even impossible to evaluate viewpoints that are inaccessible or out of reach. To address this limitation, we explore two methods. The first is the world in miniature, or WIM. It provides a small virtual model of the environment that users can examine from different angles. The second is cross-reality, or CR. This allows users to switch from MR to fully immersive VR. In VR, navigation is no longer limited by physical walking. Users can teleport to viewpoints that would be unreachable in MR. Together, these two methods show strong potential for supporting SPT in MR. But how does this relate to existing research? SPT has traditionally been assessed using paper-based or static tests. These typically involve 2D viewpoint shifts and multiple choice formats, offering very limited interaction. In VR research, the focus has mainly been on embodied perspective taking rather than dynamic spatial problem solving. Some perspective aids have been explored, however, SPT tasks in MR remain limited. WIM was originally introduced as a synchronized 3D miniature of a virtual environment and later extended with portal transitions to full-scale VR. It has shown benefits for spatial overview, accessibility, and memory enhancement. Although it has been applied in MR for object placement, its use in SPT tasks is still limited. Similarly, CR research using video pass-through headsets often focuses on transition techniques. Its application to SPT tasks remains underexplored. While CR has been shown to reduce task time and errors and to improve spatial accuracy, the evidence is still limited. Moreover, it remains unclear whether improvements were due to full-scale VR itself or to bird's-eye perspectives. After reviewing prior research, we identified two gaps. First, SPT has rarely been studied in dynamic, interactive spatial contexts. Second, although WIM and CR have been examined as systems, their potential to provide access to otherwise unreachable viewpoints in MR is unexplored. To address this gap, we introduced a novel 3D SPT task and implemented the two methods to support SPT in MR. After a successful pilot, we conducted a formal study with 80 participants to evaluate the effectiveness of both methods. We designed a practical task in which SPT was essential to solve it. The task took place in MR, where an empty physical room was overlaid with a pre-arranged virtual office containing desks, chairs, and computer monitors. To ensure the need for SPT, we added a virtual staircase that introduced physically unreachable viewpoints from the upper stairs. Framed as an interior design problem, participants were asked to place 5 virtual privacy partitions. The goal was to block sightlines to the computer monitors from the staircase, simulating a scenario in which clients standing on the stairs should not see sensitive information on the screens. In WIM mode, users could spawn a partition and move it using the grab controller buttons. Each time they did so, the WIM updated accordingly. The WIM served exclusively to provide additional viewpoints. Participants could not move the partitions within it. This design emphasized adding perspective through visualization rather than reducing movements. In CR mode, users also could spawn and move partitions. Instead of a WIM, they could switch between MR and fully immersive VR. Once in VR, they could teleport onto the stairs and check whether the monitors were visible from that viewpoint. Like the WIM, VR served exclusively to provide additional viewpoints. Users could not move the partitions while in VR. Once users were happy with their partition placement, rays were cast from the monitors to the staircase to check visibility. The task success score was calculated as the ratio of green rays to total rays. We decided to go for a mixed design study in which participants completed the task twice, once in WIM mode and once in CR mode. To reduce learning effects, we created a second scene and counterbalanced both the mode and scene order across participants. Before the main study, we ran a pilot with 14 participants. In this pilot, we compared WIM mode to a baseline condition without WIM or CR. The results showed a significant improvement in task success with WIM. All participants also reported that they found it helpful. After a successful pilot, we recruited 80 participants for a formal user study comparing WIM mode and CR mode. The sample covered a wide age range, including participants up to 89 years old. The study began with a welcome session where we explained the procedure and distributed pre-questionnaires. Participants then started with either WIM or CR mode and with either Scene 1 or Scene 2, depending on their assigned condition. After a short tutorial, they completed the task and evaluated the feature and its usability. They then repeated the task using the other mode and the other scene. Moving on to the results, let's first look at the task success score. We found no significant difference between WIM and CR, indicating that both perspective aids were equally effective. However, Scene 2 resulted in significantly higher scores, likely due to its circular staircase layout, which allowed more effective partition placement. Overall performance was high in both modes, suggesting that both effectively support SPT in MR. While performance was similar, differences emerged when we looked at efficiency. Task completion time was significantly shorter in WIM mode. In CR, longer times were mainly due to navigation efforts. Each switch to VR added about 28 seconds, and each teleport about 6 seconds. We also found that participants with more VR experience completed the task faster, although experience did not affect how often they switched or teleported. Overall, WIM provided a more efficient way to access additional perspectives. Beyond objective performance, we also examined subjective evaluations. Both systems achieved excellent usability ratings. However, the difference was statistically significant, favoring WIM. This may be because users could directly inspect updates in the WIM. Interestingly, preference told a different story. Although usability favored WIM, participants rated CR significantly higher for task support, sideline visualization, decision-making, and overall preference. While WIM was seen as more user-friendly, many valued the CR ability to switch to VR and verify results at full scale. We also found that older participants tended to prefer CR. A likely explanation is that full-scale perspectives better support spatial reasoning. Before concluding, it is important to acknowledge some limitations. Performance was influenced by the physical layout and by a discretized success metric. We did not include a combined WIM and CR condition to avoid overloading participants. In addition, the WIM size and placement were fixed, and we lacked objective measures of WIM usage, such as eye tracking. In conclusion, both WIM and CR were highly usable but offered different advantages. WIM enabled faster interaction and was perceived as more user-friendly, making it well-suited for quick spatial assessments and overview reasoning. In contrast, CR was preferred overall due to its full-scale embodied perspective, which makes it ideal for complex designs that require strong SPT skills. Looking ahead, several next steps remain. We plan to benchmark our system against established SPT tests and extend it to additional SPT task types. We also want to explore combinations of WIM and CR to leverage their complementary strengths. Finally, involving more professional designers will help validate the approach in real-world planning contexts. That concludes our presentation. Thank you for your interest in our work.